In the last video, we saw how to multiply and divide with integers. Multiply two integers together. Divide two integers if one goes evenly into the other. And the idea of their unit fractions and how they had that 2 over n chart, that doubling chart. And we saw that we could multiply fractions by integers, and they would do that by, you take this number here that's on the left and you write like that, and then you double. And they were good at doubling fractions. Well, doubling a half is 1, but if it was some other denominator, they might have to use the 2 over n chart and double and double. And actually, we're trying to achieve 8, so the answer to that one is 12. That's what we saw at the end of the last video. But what if I switch the order of the two things around? Well, we have to make our chart so that the thing on the left is what we're sort of building our chart around. So now I have 1 times 8. But if I double it, well, that's a problem because I'd be bigger than the thing that I'm trying to achieve. So I'm not going to do that. So what they would do instead is, one thing they can do is start dividing. Here in this one I doubled each side. What if I halved each side? Well, half of 1 is a half, and half of 8 is 4. They were really good at taking halves of numbers. And actually I'm done now. Remember, you're trying to get numbers here that add up to 1.5. Well, 1 and 1/2 add up to 1.5. So we add these two numbers together and get 12. Now you might say, why don't I just switch around the order and do it this other way? But that's not how they would have thought about it. So if we see the integer on the left, we're going to do it this way. Here's another example. So we say 1, this one has a quarter in it. Now you might feel like, okay, well I have 1, and I just need a fourth more, so why don't I just go straight to saying, 1/4 here. This is the temptation. But that is not what they would do most of the time, although sometimes they would not show their work for the step, but very common to see and to see them do would be just like if you're multiplying by, let's just say 8, they wouldn't just jump straight to saying 896. Instead, they would like sort of build up to it. Same thing with fractions. They don't jump to 1/4. They build sort of up to it or down to it, however you want to look at it. But they would get to 1/4 through 1/2. And then they would take half of each side. You take taking half of a fraction is real easy because you double the denominator, as opposed to doubling a fraction, which sometimes requires the 2 over n chart. And now I see the 1 and the 1/4. 12 plus 3 is 15. So it's very common to see this, although sometimes they don't sort of show all their work, and sometimes they did skip straight to something like this, but most common they would show the entire sort of chart building to it. So here is 20 times 1 3/4, but they don't have 3/4 as a thing, but they do have 1/2, 1/4. That's their way of saying 1 3/4. And since the 20 is on the left, I'm going to go like that. 1/20, half, 10, 4, 5, and that's real convenient because those are exactly the three things that I need. So 20 plus 10 plus 5 is 35. And I recommend that you pause as when you see a question and try to think about this to simulate what would happen in actual class. Now, other fractions that they were very comfortable with was the fraction 2/3. And 2/3 is a fundamental fraction in Babylonian times. It's the only fraction that's not a unit fraction. Now, you might look at this and say, wow, how am I going to do that? Like, how am I going to do it? If I try doing what I've just been doing and say 1/1/6 and half 3, it's like 1/4, 1.5. Like, how am I going to achieve fractions that add up to 2/3? Well, the good news is that you don't have to do that, because the other way that you can start is by actually jumping to 2/3. And they were very good at knowing 2/3 of a number. I mean, I know nowadays you would probably do 2/3 of 6 by working out 1/3 of 6 is 1/3 of 6 is 2, and double that to get 4. The speculation is they would answer this question by thinking 1.5 times what number is equal to 6, and they would say 4. However they did it, they were really good at knowing 2/3 of numbers. And that's why the answer to this question is 10. Now, a kind of funny thing that you see is when they're dealing with 1/3. So we make 1/18, and they would not, just like you wouldn't jump to 1/4 in this example, you would get to 1/4 through first going to 1/2. Believe it or not, they seem to find it easier to first get 2/3 of the number, and then take half of each row, and 1 1/3 is 24. So this is kind of like an idiosyncrasy, like something kind of strange about when we look at it. We just wonder, well, if they're really good at doing 2/3, why aren't they really good at just jumping to 1/3? Yet, over and over again in their documents, especially with the main one, there's only a few documents actually that we have. One's called, the big one is the Rhind papyrus. That's, I think, about 90% of what we know about Egyptian math comes from a single scroll called the Rhind papyrus. And I would like you it's just to calculate the way the Egyptians would, to do 2/3, even if you cheat and first figure out 1/3 and then kind of do the 2/3 and put it up here as if you did it first. It's up to you. They were so serious about this that they would even, in their math, sometimes have students practice a question like this. This question is silly. If you look at it, what is it? You pause, think about that question. Okay, welcome back. Well, this number here is just 2. 2/3 and 1/3 is 1. So it's just 24. Yet, we see them practicing 2/3 of 12, they would know was 8. And 1/3 is half of that, which is 4. Then they would add these three things together to get 24. But they wouldn't say, oh, this is just 2, and 12 times 2, I'm so good at doubling. So maybe this was just their way of really practicing 2/3, but we see that a lot. So if I write a question like this, I'd want you to answer it that way and not turn the 1, 2/3, 1/3 into the number 2. Now you can also multiply fractions by fractions. Like here's modern question, 2/7 times 7/4. And we're so good at going like that and getting 1/2. But back in their time, 2/7 was written as 1/4, 1/28. And 7/4, which is the same thing as 1 3/4, was written as 1 1/2. That's just how they write the question. I'll put parentheses around just to... So this is the way they would phrase that question. And they're going to get 1/2 as their answer also. It's going to be a lot more complicated. So we put a 1, and we put this thing on the right. And we look over here. Well, I have the 1 already, so I need a 1/2, so I do 1/2. Taking half of fractions is real easy because you just double, especially unit fractions, you just double the denominator. And taking 1/4, we just half the thing we just had, so we double all the denominators. So the answer, we use all 3 of them. It's all 6 of these fractions, which I'm just going to write out. 1/4, 1/8, 1/16, 1/28, 1/56, 1/112. I will permit you to do like a modern, like common denominator thing to see what the answer is. The Egyptians were really good with their fractions, so they would have like recognized that some of these fractions like fit together nicely and that this is equal to 1/2. We're not going to get that good at this to be able to recognize that. So I will permit you to go modern for a bit just to see how to translate their answer. At least we got it as a unit fractions. Here's 1/112. This is a fraction times 2, but instead of writing it as 2, they write it this way. It's not practical, it's just for practice with your 2/3. Now, is there a trick for going to, what is 2/3 of 1/12? Think about that for a second. You could pause and think about it. Okay, welcome back. So, like when you take half of a fraction, you end up doubling the denominator. Well, if you take 2/3 of a fraction, you end up multiplying the denominator by 3/2, which is 1.5, and 1.5 times 12 is 18. So I'm just going to write down 18, 12 times 3/2 is 18, and that becomes the new denominator. And then 1/3 is just half of 2/3. We double the denominator to get 1/36. So our answer has all 3 of these. And it's 112 plus 118 plus 1/36. But I will allow you to go modern, and you'll get 6/36, which fortunately reduces to 1/6. Of course, 112 times 2 is 1/6, but this allows us to practice stuff like 2/3 of a fraction, multiplying the denominator by 1.5, and things like that. So that takes care of all the multiplication. Now let's move on to a division. Now we saw division already, where if the answer became, but what if there's a remainder? So the first question I want to show you is 15 divided by 6. Nowadays, we answer this pretty easily, but here's how they might do that question, or here's how they would. So we put 1 and 6, then we double. This is how you do the division, and we're trying to get to 15, but I have 6 and 12. If I double again, I'm going to be at 24, which is too big. But I don't have 15. These two things add up to 18. So I have to think, okay, I have 12 already. I need 3 more. Well, I can do that. I can go back to the beginning and take half of each of those. And that's very convenient because that's just what I needed. 12 and 3 is 15. And that's why the answer is 2.5. So that's what happens when when the integers don't add up to my goal, I have to start taking fractions, and it can get pretty complicated. This is a good first example, though, 15 divided by 6. Here's another one, 15 divided by 4. For that one, 1, 4, 2, 8. I'm not going to go to 4, 16. That's already too big. So I look at what I have. I have 8. I have 12 so far. So I need 3 more. Well, if I take half, this is half of the first line. That would get me 2. That's good because I needed 3 more. So this 2 is going to lead me to dividing everything in half again. And now all 4 of these things add up to 15. So the answer is 3, 1/2, 1/4, which is the same thing as 3 3/4. 16 divided by 3. Now, if you try 1, 3, 2, 6, 4, 12, the 12 and the 3 add up to 15, which is getting close. I'm only 1 away. If you try now going to 1/2, 1/2 of 3 is 1 1/2, you kind of find yourself actually, well, that's all right. We're actually not going to use 1/2 because sometimes if 1/2 wasn't working out nicely for them, they would instead do 2/3. 2/3 of 3 is 2. Actually, I hope you don't mind, I'm going to change this question to 17, just for instructional purposes. And now, 12, 13, 14, 15, 16, 17. So the answer is the 1 and the 4 and the 2/3, which is 5 and 2/3. Here's another one like that. 51 divided by 9. 1, 9, 2, 18, 4, 36. So I have 36 and 18. Make that 36 and 9 add up to 45. So I need 6 more. Well, conveniently, 2/3 of 9 is 6. So the answer is, again, 5 and 2/3. Now let's go back to that question I was going to say before, 16 divided by 3. 1, 3, 2, 6, 4, 12. Don't go to 8, it's too big. So I have 15, so I just need 1 more. Now your temptation might be, okay, half isn't good, but I need 1 more, which is 1/3 of 3. So the temptation is just to go to 1/3, but they wouldn't. If they knew they needed 1/3, they would usually say 2/3 of 3 is 2, then cut these in half to say 1/3 is half of 2, which is 1, and then use that. So this line, which seems pretty unnecessary, but we see it over and over, so we'll put it in there just for fun. If you know the answer is 1/3, do 2/3 first, and then go to 1/3. So we're really walking in their shoes. 16 divided by 3 is 5 and 1/3. Okay, I just have a couple more questions. Here's 22 divided by 12. I wanted to show you why there's actually, I could do this 2 different ways, which is kind of interesting. I can't double it because I'll already be at 24. So if I go to half and have 6, so now I'm up to 18, I need 4 more. Well, where could that 4 come from? Well, it could come from doing 2/3. They're really good at knowing 2/3 of 12 is 8. That's real convenient because I needed 4 more. Right, these two add up to 18. I need 4 more, so I take half of the 2/3. And that's the 4 more that I need. And the answer is 1, 1/2, 1/3. Half plus 1/3 is actually 5/6. Now I'm going to show you the same question. And this is the answer, 1 5/6. But look what would happen if I thought instead, oops, don't need to write that. What if I jumped straight to the 2/3 and had the 8 there? Then I'd notice that the 12 and the 8 add up to 20, which is just 2 away. Well, I can get to 2 really easily by doing half of 2/3 and half of 1/3. Half of 1/3, I just double the denominator. And I end up using the 1. So I could also write the answer as 1, 2/3, 1/6. These are both correct because 1/2, 1/3 evidently is equal to 2/3 plus 1/6. They're both equal to 5/6, and that gets kind of confusing, but the Egyptians would be very comfortable. Sometimes they would, if this appeared, they might change it to this, or vice versa. If they just knew this sort of identity that 1/2 plus 1/3 is the same thing as 2/3 plus 1/6, and they would often interchange these two things. Like if one of them popped up, use the other. But you can see by starting with 2/3 instead of starting at 1/2, we get a different looking answer. Now, in the previous lesson, I showed you that 6 divided by 10, which is basically 3/5, divide 6 loaves of bread among 10 men. And I said they wrote it as 1/2, 1/10. Well, we can actually see where that comes from, because this is the first time where this number, the 6, is smaller than the 10. So we go 1, 10. Yes, it is that number there. So we're already bigger than 6, but we still write that as our first thing. Then we can say 1/2 is 5. Well, that's getting close to 6. And I see this a lot. It's funny, they're able to just skip ahead and say, okay, I really need 1 more, so why don't I just jump straight to 1/10 is 1. Maybe when it's the number 10, it's obvious to them that 1/10 of 10 is 1. Maybe they take 1/5 of both sides. It's tough to say why, but we see this. We don't see a big complicated way of getting to 1/10 the way we do. Like if you wanted to get to 1/6, you would get there through 2/3, 1/3, 1/6. But to get to 1/10, they seem to just have no problem jumping to 1/10 when it's convenient for them. But no, never would they jump to 1/6. That's always coming through 2/3, 1/3, 1/6. And that's our answer, 1/2, 1/10. That was the thing from the day before. That 2 over n table? Where does it come from? Well, 2 divided by 5. 1/5, that's already bigger than 2. And if you try to do 1/2 and 2.5, you're not going to get to the number 2 very well. But check out what happens if I go 2/3. Now, they would have been very comfortable with the fact that 2/3 of 5 is 3 1/3. Maybe you could think 2/3 of 10 is 6 2/3. So 2/3 is 3 1/3. Or maybe you could think that 2/3 of 5 is the same thing as 1/3 of 10. Whatever you need to do to get comfortable with the fact that 2/3 of 5 is 3 1/3, again, that's something they would know really well. So here's what's neat about this. They would also be pretty comfortable now taking half of that and knowing that half of 1 1/3 is 1 and 3 1/3 is 1 2/3. It's pretty clear that if you double 1 2/3, you get 2 4/3, which is the same thing as 3 1/3. But again, this is something they'd be pretty comfortable with. Now we're trying to achieve the number 2, and finally we're at least smaller than it. We just need 1/3 more. And they jump straight to this. Now how do they know? Well, you might look at this thing and say, well, that's the same thing as 5/3. And my goal is to get 1/3. So 1/5 of 5/3 is 1/3. So I'll take 1/5 of 1/3, which is 1/15. Anyway, this is like more of like an art than a science, to tell you the truth. So we get 1/3 and 1/15. And if you take a look at the 2/n chart, you'll see that that's what they say for 2/5. But this might have taken them some experimentation, and maybe they're just not showing all their work, but this is all they show for it in the Rhind papyrus. And I'm just kind of speculating how they might have jumped from here to there. Maybe they started right at the beginning and said, well, I need 1/3, and 5/15 is 1/3, so I'm going to divide by 15. Who knows how they got that, but that's what they needed. They needed 1/3, and 1/15 was the way to get it. Okay, the last question for today, I'm going to show you 2 different ways. Why don't you take a second to pause and see if you can come up with doing this, and then I'll show you how it can be done 2 different ways. Welcome back. One way to do this is to start with half. And notice I've got 5, I need to get to 7. We see this sometimes. Sometimes they jump down to 1/10. And then they jump up by doubling it. Double 1/10, it becomes 1/5. You double not to 2/10, but to 1/5, you half the denominator. So that's one way of doing this question, 1/2, 1/5. So I guess they're pretty good with 1/10, but they didn't just jump to 1/5, saying, oh, I need 2 more, and 1/5 of 10 is 2. They would jump down to 1/10 and then double it. Now, I don't expect you to come up with the exact answer that they did, because different people there might have done it different ways, but I just want you to experience their method so you could noodle around with it. The other way of doing this is to start with 2/3. So 6 2/3 is pretty close to 7. So I just need 1/3 more. And the way we see them do it is they go 1/3 is 3 1/3. And maybe they notice now that this is the same thing as 10/3, so that they can almost imagine the 10/3, 9 of them being the 3. So then they jump now to 1/30 is 1/3, and those are so their answer is 2/3, 1/30. And I'm pretty sure in the Rhind papyrus, when they say divide 7 loaves of bread among 10 men, this is the answer they got. The 2/3, 1/30 is why, is that better than 1/2, 1/5? I don't know, but they're both right. Okay, so that's going to do it for today's lesson. What we've seen today is how multiplication and division can be done. Multiplication with fraction times integer, or fraction times fraction. We saw that 2/3 was something they were very comfortable with, so much so that to get to 1/3, they would do 2/3 and then take half of it. And then we see that division, where it doesn't go in evenly, was accomplished with some creative uses of taking halves or sometimes two-thirds and kind of hoping it all works out.